Hi math experts, good day. In this video we're going to have more examples on evaluating limits of algebraic functions. So I will be giving 4 more examples to clearly understand the concept of evaluating limits of algebraic functions. So let us begin with number 1. So the first algebraic equation to be evaluated is we have limit of the quantity of x plus 4 times square root of 2x plus 5 as x approaches to 2. Okay, this one. So just directly substitute or distribute the limit notation to every expression. So we have here limit of x plus 4 times limit of square root of 2x plus 5 as x approaches to 2 as x approaches to 2. Okay, so next is we have limit of x plus limit of the constant 4 as x approaches to 2 as x approaches to 2. Just simply distribute the limit notation in the given expression. Next, times the limit of times the square root of the limit of 2x plus limit of the constant 5. Okay, so square root of the limit 2x plus limit of the constant 5. Then don't forget to write as x approaches to 2 or where your limit x approaches to. So next, we have here now, so since our x approaches to 2, just simply substitute this value to our variable x here in the given expression or given function. So we have limit of x, that is 2. So always remember that simply substitute. Then we have plus limit of the constant 4. So any constant or the limit of any constant is still the same with the given constant. So we have limit of constant 4, that is 4, times the square root of the limit of 2x. So you are just going to multiply 2 by 2. So 2 times 2, that is 4, plus that is 2 times your value of your x since 2, so 2 times 2, that is 4. Okay, so limit of the constant 5, that is 5. So now we have to simplify. 2 plus 4, that is 6. Okay, so 4 plus 5, that is 9. So therefore 6 square root of 9. So square root of 9, that is 3. So 6 times 3, that is 18. So 18 is the answer, or the limit of the function x, the quantity of x plus 4 times square root of 2x plus 5 as x approaches to 2, that is 18. Okay, so for number 2, we have limit of the function x squared minus 4x plus 3 as x approaches to 2. Okay, so in this given function, simply distribute the limit notation to each part of the function. So we have limit of x squared minus limit of 4x plus limit of the constant 3 as x approaches to 2 as x approaches to 2 as x approaches to 2. Okay, so next, make the limit form in its simplest form. I mean, make it in a simple way of writing. So just square both limit and the variable. So in the first part of the function, so we have limit of x squared minus limit of 4 times limit of x plus limit of 3. So it should be limit notation and the variable only that will come together, or that will be beside to each other. Other than that, it should be written in other form. So we have x approaches to 2, x approaches to 2, and x approaches to 2. Now, since our limit of x, or where our limit approaches to, is into the values 2, value 2, so simply substitute x with 2. So that is why 2, and you have to square that one because there is a square in the original form of the function. So 2 squared minus 4 times 2, since you are going to substitute 4 times 2, since you are going to substitute x with 2. Then the constant 3, the limit of the constant 3, that is 3. So simplify 2 squared, that is 4, minus 4 plus minus 8, that is negative 4, times 2, that is negative 8, plus 3. So that will be 4 minus 8, that is negative 4, plus 3, that is negative 1. So negative 1 is the resulting value of limit of the function x squared minus 4x plus 3 as x approaches to 2. So that is for number 2. So let us proceed for number 3. So for number 3, let us write it below. So for number 3 example, we have limit of 4x plus 2 all over x plus 4 as x approaches to 3. So again, directly distribute the limit notation. So we have limit of 4x plus 2, x approaches to 3. Okay, next, denominator, limit of x plus 4 as x approaches to 3. Okay, that's it. So then distribute again. So we have limit of 4x plus limit of 2, x approaches to 3, x approaches to 3. Then limit of x plus limit of the constant 4 for the denominator, then approaches to 3, x approaches to 3. So now let us have the substitution process. So just simply substitute the value of your limit of x to the variable x in your given function. So limit of 4x, that is 4 times 3, 4 times 3, plus limit of your constant 2, that is still the constant, so that is 2. So for the denominator, limit of x, that is 3, plus limit of 4, constant 4, that is still 4. Okay, so we have to simplify 4 times 3 plus 2, 12, that is 14 over 3 plus 4, that is 7. So we have 14 divided by 7, that is 2. So the value of the limit 4x plus 2 over x plus 4 as x approaches to 3 is, we have 2. So that is for number 3. So this is the process of obtaining or evaluating this limit. So next we have example number 4, the last example for this video. We have limit of the quantity of 4x minus 3 times the quantity of x squared plus 5 as x approaches to 2. So again, simply distribute the limit notation. So we have limit of 4x minus 3 times limit of x squared plus 5 as x approaches to 2, x approaches to 2. So since it is not yet distributed to whole parts of this two expression, then simply distribute the limit notation. So limit of 4x minus limit of the constant 3 as x approaches to 2, x approaches to 2, times the limit of x squared plus limit of the constant 5. So don't forget to write where your limit of x approaches to, or to what number it approaches to. So we have here, then write into simplest form of the limit notation. So we have 4 limit of x minus limit of 3 times limit of x squared plus limit of 5. So x approaches to 2, x approaches to 2, x approaches to 2. So now, since we already have this kind of form, just directly substitute the value of your, where your x approaches to every variable here. So we have x and x here, okay? So we have 4 limit of x, that is 4 times 2, minus limit of the constant 3, that is still 3, times limit of x squared, that is 2 squared, plus the limit of the constant 5, that is 5. Okay, so limit of the constant 5, that is still 5. So we have 4 times 2, that is 8, minus 3 times 2 squared plus 5, that is 4 plus 5. Okay, so we have 8 minus 3, that is 5, times 4 plus 5, that is 4 plus 5, that is 9. So the answer is 5 times 9, that is 45. So you can say that limit of the quantity of 4x minus 3 times the quantity of x squared plus 5 as x approaches to 2 is equals to 45. So that's all. Let us have a glance to the 4 examples given that we had solved already. So for number 1, number 2, number 3, and number 4. So math experts, I hope you understand now the concept of limit, and most importantly how to evaluate limits of algebraic functions. So with these examples and guide. So don't forget to subscribe for more updates for my incoming videos. So my next videos will be all about rational expressions. So you are going to simplify rational expressions and the likes. So bye bye and God bless everyone. Be always math expert.